Look closely at the details of his shoes, pants, jacket, shirt, hands, and head. This short animation, Jerry's Game by Pixar, made in 1997, just 2 years after Toy Story 1, is a landmark in animation history. Why? Because it was the first Pixar short film with a human main character, produced with the goal of taking human and cloth animation to new heights. It was also the first time the famous subdivision surface method was practically used to model parts of a character like the ones we just mentioned. This method was introduced in 1978 by Edwin Catmull, the co-founder of Pixar, and James H. Clark, the founder of Silicon Graphics. Wait, did that sound familiar? Yes, we're talking about the Catmull-Clark method. This method created a wave that revolutionized the entire animation industry. Today, it's still a cornerstone in almost every 3D software out there. Maya, 3D Max, Houdini, and of course Blender, where we've already played with this magical modifier in the last episode. Before this animation, in Toy Story 1, characters like Woody were modeled using a type of geometry called non-uniform rational B-spline. Fancy name, right? But don't worry, we can just call them NURBS. However, NURBS had many limitations. While it's still used today, mainly in industries where precision is crucial, like in industrial 3D modeling, it's not as common in animation anymore. So, we don't need to worry too much about it. Now, as promised, in this episode, we're going to dive deeper into subdivision surface and use them in a more hands-on way to model this episode's project, which is Andy's chair. So, what exactly is a subdivision surface? And what's the benefit? Okay, let me show you. As you can see, this plane is made up of 4 vertices, 4 edges, and 1 face, right? When we apply the subdivision surface, if we change the method to simple, it divides each face into 4 smaller faces in each step. Here, the steps are controlled by the levels viewport. In the second step, these new faces are again divided into 4, making 16 in total. With each additional step, the number of components keeps increasing, making the mesh denser and adding more detail. With the Catmull-Clark method, not only does it divide the faces, but it also smoothens the mesh, giving us a softer surface. But here's the catch. We can't directly interact with these new components until we apply the modifier. And that's actually a big advantage. Why? Because it lets us work with a simpler, low-component mesh, giving us way more control and saving us tons of time. This simplified mesh is called the control mesh, and it makes modeling much easier, since you can work with fewer components to shape it however you want. Remember in the last episode when we were modeling that 3-key drawer handle? Imagine if we had more points to deal with instead of just 4. It would have been a nightmare to shape that curve, right? Remember that edge of the clock in Toy Story 1 that I showed you in the first episode? The Catmull-Clark method could have been easily fixed that problem, right? So, why didn't Pixar use it? Catmull-Clark algorithm had been devised in 1978. They definitely knew about it and could have used it. But the thing is, while subdivision surface make modeling easier, they also use more of your system's resources. The more higher the viewport levels, the denser the mesh, making the scene heavier and harder for the computer to handle. In a sense, there is never just one prop. There are many models which can make the scene extremely heavy. This is why Pixar focused on optimizing the scene, giving more detail to the main assets and characters and less to the background models or the models that were far from the camera. Even though Pixar had powerful computers for their time, they still weren't capable of handling too many geometries, so they had to optimize carefully. This is also why in Blender, the subdivision surface modifier gives you 2 properties, one for the viewport and one for rendering. For instance, if your viewport level is set to 1, but the render level is set to 4, your mesh will render at a higher subdivision level, keeping your scene light and avoiding those dreaded crashes. Okay, I had to show you the render button, and speaking of rendering, I know you're itching to hit that render button. It's like magic, turning all your hard work into a polished piece of art. But don't rush just yet. That button is your gateway to greatness in the 3D world, but we've got a bit more ground to cover before you're ready to make money with it. Patience, my friend. Alright, so that's the story of the Catmull-Clark method in subdivision surface. Just remember, don't increase the viewport levels unless you really need to, okay? you can achieve amazing results by just enabling shade smooth and keeping the viewport levels low. Now it's time to download the blueprints for this episode from the link in the description, and let's dive into creating Andy's chair with this new technique we've just explored. Alright, I've imported and set up the blueprints as usual, but there is one small difference this time. We're working with back view blueprints for the first time, so the setup is a bit tricky. For importing the back view blueprint, make sure to first switch to the back view by pressing Ctrl 1, then go ahead and import the back view image, okay? Now let's say I create a cube and switch to the back or front view, and you're gonna notice that the blueprints are blocking the view, making it impossible to see the object. So to fix this, I switch to the front view, where the front image is the one blocking the view. In the outliner, I click on this red image icon for that image, which opens up its data properties here. And here under the depth option, select back to push the blueprint behind the object, so you can clearly see what you are working on, okay? I'm gonna do the same thing for the back view, select the back image, and set its depth to back as well, okay? Now the blueprints are properly set up, and we're ready to start modeling. Okay, let's begin by modeling the chair frame. You might consider using the same method we used for modeling the drawer handle with curves, adjusting the points to shape the frame. But while this approach works, there's actually a simpler way to model this object. First, we need to install an extension in Blender, okay? Just don't worry, it's nothing scary. You might have encountered extensions in other softwares. They simply add extra features to the software and making our work easier. The extension we're going to install will add more mesh to the mesh section in Add menu. To install it, go to the Edit menu and click on Preferences, then head over to the Extension section. And if you don't see this section, please update Blender. I'm currently using version 4.2. Make sure you're connected to the internet, and here type Extra Mesh in the search bar and install the Extra Mesh Objects add-on. And that's it. Simple as that. You'll see that the add-on is installed, and now if I press Shift A and go to the Mesh section, you'll notice there are a lot more mesh options available. Very cool, right? Just feel free to click on each one and test them out if you want. Alright, let's switch to the back view, press Shift A, go to Mesh, and hover over Single Vert, and click on Add Single Vert. Alright, now if I press G and move my mouse, you'll see that a single vertex is created. No edges or faces, just one vertex. Very simple, right? I'll move this vertex up here and try to center it in this section. Okay, press E to extrude, click here, press E, click, again E, click, and try to extend this line along the center of this frame all the way down. But let me undo that. Actually, there is a better way, okay? Instead of doing it all in one go, I'm gonna extrude once, bring the vertex about here, and then extrude again to place the next vertex over here. Great. I'm gonna adjust this vertex slightly to make sure the line stays centered in this section. Now I'll select the vertex and press Ctrl B to activate bevel. And as I move the mouse, nothing happens because by default, Blender wants to bevel edges, but we want to bevel the vertex. So I'll press V, and now as I move the mouse, you're gonna see the bevel is applied to the vertex. Very cool, right? Alright, I'm gonna use the scroll wheel to increase the number of points and click to apply the bevel. Down here, you can see that vertices is selected, whereas before, we were working with edges, right? Don't worry about the other side for now. We're gonna fix that with a mirror modifier. Right, let's switch to the right view and match it with the reference. I'm gonna select all the vertices, move them to the right and rotate them. Remember, you can hold Shift to make finer adjustments. Okay, I'm trying to ensure that this line stays centered in this view as well, okay? Now I'm gonna select the lower vertex, press E to extrude, and move the vertex to about here. Okay, now I want to adjust it slightly, so let me show you a neat trick. If you press G once, you can move the vertex freely, as always, right? But if you press G again, now we can move it along its axis. Very cool. So GG, and I'm gonna move the vertex. Alright, next I'll press Ctrl B, then V to bevel it and shape this curve according to the reference. We are really getting good at modeling, aren't we? Alright, now I'm gonna add a mirror modifier, and that's done. Okay, let's add some thickness to it. Since we are currently working with a mesh, and earlier we were using a curve, remember that the bevel option for adding thickness is specific to curves, okay? Not meshes, just curves. So we need to convert this mesh to a curve to add thickness. Don't worry, it's very simple. I'll switch back to object mode, select the object, right click, convert to curve. Now our mesh is simply converted to a curve, but notice that the mirror modifier is applied automatically and we can't adjust it anymore, okay? I'm gonna click on the curve data icon, and as you can see, we are now in the curve data properties here. I'm going to head to the geometry section and adjust the bevel depth to achieve the desired thickness. Now that we are familiar with the magical Catmull-Clark method for subdivision surface, we know that we can use it to smooth things out, right? So I'm going to reduce the resolution to 2, activate Shade Smooth, and press Ctrl 3 to apply a subdivision surface with viewport levels set to 3. And there you go, we've modeled this part with ease. Now let's move on to the lower frame. You should be able to create this on your own by now, but let's do it together. Okay, I'm going to select this piece and hide it with H, add a vertex, move it slightly higher, extrude it to here, and extrude once more to place it over here. Okay, now I'm going to adjust the vertex positions, press Ctrl B, then V to bevel and match this curve to the reference. Select all the vertices, switch to the front view, move them to the right, rotate, and match them to the reference in this view as well. Okay. I'm going to tweak the lower vertex to ensure it's properly positioned in both views. Okay. Now add a mirror modifier, change the axis to Y, press Tab, right click, and convert to curve. I'm going to go to the object data properties, adjust the bevel depth, reduce the resolution to 2, activate Shade Smooth, and press Ctrl 3 for a subdivision surface with level 3. Finally, I'll add another mirror modifier, and we're done. Press Alt-H to unhide the object we hid earlier, and there you have it. I highly recommend you go through this process yourself to ensure you've mastered this technique, okay? And once you've practiced, let's move on to modeling the chair backplate using the magical Catmull-Clark method with subdivision surface. Alright, switch to the front view, add a cube, and move it up here. Press Tab to enter edit mode, select all vertices, and scale down along the Z-axis. I'm gonna move these vertices up, then scale down along the X-axis. Now switch to the right view, go back to object mode, move the cube to this spot, and in edit mode, scale it down along the Y-axis. Now it's time to add a subdivision surface modifier. Okay, increase the levels viewport to 3, go back to the front view and press Ctrl R to add an edge loop in the middle. Now, simply adjust the vertices of the original mesh, which is also known as the control mesh or control cage, to match the reference. Okay. Now I'm going to select these vertices and move them down. Okay, then select these and move them up a little and bring these down a bit. Alright, let's move on to the lower vertices. I'm going to adjust them and try to match them as closely as possible to the reference. Okay, I'm going to make some small adjustments here. Alright, now if you switch to object mode, you'll see that the shape of the backplate has turned out well. The only issue is that it's a bit too flat. To fix this, go back to edit mode and add an edge loop close to this edge loop and another one close to this. Okay, these are called supportive loops, which help make the edges of the geometry sharper. Okay, and also don't forget to activate Shade Smooth, and you'll see it looks great. Now it's time to give this plate a slight curve. To do that, let's get familiar with another awesome modifier. Alright, select the object, go to the modifiers tab, and this time, go to Deform section and choose Simple Deform. Immediately, you'll see some cool stuff happening. This is a very useful and beloved modifier. Just keep in mind that the position of the object origin is very important for this deformer. So, make sure the origin of your object is centered for the modifier to work correctly, okay? Since we want to bend the model, simply select Bend here, and if you adjust the angle option, you'll see the object start to bend. But it's not bending along the right axis right now, okay? So we'll choose the Z-axis here. Then change the angle to a negative value to bend it in the correct direction. And there we go. Now switch to the right view, go into edit mode, select all the vertices by pressing A, and rotate them slightly in this direction. And that's it for modeling the chair backplate, okay? Modeling the seat is very straightforward. Add a cube, go into edit mode, and scale it according to the reference in this view, switch to the right view, and adjust the vertex positions here as well. Okay, add an edge loop in the middle here and another one here. Now, add a subdivision surface modifier and set the viewport levels to 3, okay? Now, to make the thickness more noticeable, you simply need to add 2 supportive edge loops here. Alright, now let's deform it. Before that, don't forget to enable Shader Smooth. Go to the Deform section, select Simple Deform, choose Bend here, activate the Y-axis, and wait, a new problem. Why isn't the bend working correctly here? Okay, let's set the object's origin to the center. Nope. Now the object origin is set to the center, so you might think, oh, I know the problem. I need to go to Object Properties and, oh, the scale is correct and set to 1 here. So what is the problem? Okay, let me help you out. When using this modifier, if you've checked everything and the Simple Deform still isn't working correctly, you need to do one simple thing. First, make sure you're in Edit mode, then press A to select all the vertices. And now if you press R for rotation, you'll see that the rotation affects how the Simple Deform operates. Alright, so you can change the rotation axis with the X, Y, and Z keys to see which axis the deformer works best on, okay? In this case, the Y-axis is the one to choose. So I'm going to press Y, type 90, and press Enter to rotate the mesh 90 degrees. Just remember that the rotation must be done in Edit mode, okay? Now go back to the Object mode, press R, select the Y-axis, type 90, and press Enter to return the rotation to its original state. I know it seems a bit odd, it is what it is for now. Okay, let's continue. And now we just need to adjust the angle and bend it to the desired degree. Switch to the front view and move it down a bit. Switch to the right view and rotate it slightly in this way. I'm going into Edit mode and reducing the thickness and moving it up a little. Okay. I'm going to adjust the position. And now I think it looks better. Alright. Here you can see the front of the seat is bent down a bit. But if you select these vertices and move them down, you'll see it doesn't quite look right. So we need an edge loop here to better control these vertices. Press Shift R and add an edge loop around here. Then select these vertices again and move them to about here. Just rotate them a bit and move these vertices up slightly. Okay. Hold Alt and click here to select this edge loop and press Ctrl Shift R to add 2 edge loops on either side and clicking here to place them, okay? Finally, add 1 more edge loop at the back here. Alright, I'm going to switch to the right view, adjusting the bend angle a little. Okay, I'm going to tweak it a bit more. And now I think it's fine. To be sure, I'm going to select this object and hide it. Now going back to the right view, I'm going to rotate this a little more, move it down just a bit, and adjust the rotation again, okay? Alright, I think it's looking better now. Okay. I'm going to unhide this object, and that's the modeling for the seat. Now let's move on to modeling the chair's leg caps. First, select the chair frame, go into Edit mode, and select this point. Press Shift S and choose Cursor to select it. Then switch back to the Object mode and add a cylinder, scale it down, and you'll see that it's placed exactly where the cursor is. Okay, press Shift S again and reset the cursor to the word origin. Poor cursor, right? It seems like we use it all the time and then quickly threw it back to its place. But let's not get too sentimental and get back to work. Alright, now go to the front view, press Alt-Z to switch to X-ray mode and go into Edit mode. Simply move and scale the vertices to match the reference. Okay, add an edge loop in the middle and scale it up slightly. Select the top face, press E to extrude it upward and adjust the scale a bit. Add another edge loop here and scale it up a little. Okay, you'll notice the chair leg is a bit short right now, but don't worry, we'll fix that in a bit. Now if you press Ctrl 2, you're gonna add subdivision surface modifier with viewport levels set to 2, and you might notice that things doesn't look quite right. Don't worry though, even Pixar released one of their short animations with a similar issue, but we're going to fix it. For now, make sure the top and bottom faces are selected, press X, and delete the faces. Activate Shader Smooth as well. Switch to Edge Select mode, hold Alt and click here to select this edge loop, press E to extrude, and then right-click. Remember, this doesn't cancel the extrude operation, but rather places the newly created components exactly on top of each other. We learned earlier that whenever you see the pop-up window at the bottom, it means the last operation wasn't cancelled. With the edge loop still selected, press S to scale it down, and you'll see how easily we created the surface of this edge. Very cool. Now let's repeat this method for the cap on the bottom part as well. First, select this edge loop, press E, and this time, no need to right click, okay? After pressing E, just press S and adjust the scale. Then click around here, press E again, S, and click around here. Repeat this once more. And finally, press F to fill the hole with a face. The reason we did this multiple times is that the extra edge loops help eliminate that weird pumpkin-like shading. And that's it for this part. Now let's fix the short leg of the chair. Okay, select it and go into edit mode. Select this point, press G. And as you learned earlier, if you press G again, you can move the vertex along its axis. But you'll notice that doesn't happen here. I didn't lie to you, it still works, but what we've selected now is a point, not a vertex. Remember, this object is a curve, not a mesh. And unlike meshes, curves don't have vertices. So let's convert the curve to a mesh so we can access the vertices. It's very simple. First go to Object Mode, and before converting it to a mesh, delete the subdivision surface modifier here, because we can add it again after the conversion, okay? So this way, we don't accidentally add the subdivision surface twice, which would make the mesh too high poly. Alright, now right click, go to Convert to, and choose Mesh. You're gonna see that the modifiers have been applied, just like when we convert a mesh to a curve. When you convert, remember that the modifiers are applied, and you can no longer access them. Okay, now press Ctrl 2 to add the subdivision surface again. Alright, go into Edit Mode, select all these vertices, and now press G twice. Okay, as you move your mouse, you'll notice that it doesn't allow you to move the vertices further. To fix this issue, press C, and now you can extend it easily. Very neat, right? Okay, now select this object and press the period key on the numpad. You're gonna see it zooms in on the selected object, and here's another handy hotkey for you. Alright, now let's sharpen some of these edges by adding support edge loops. Go into Edit Mode, press Ctrl R, and add one here, another one here, here, and one down here. And that's it for now. Alright, now let's position this on all four legs. Add a mirror modifier. The object origin is centered right now, and we want to use this object's origin for mirroring, so they're placed exactly where they should be. To do this, first select this object, right-click, choose Set Origin, and then Origin to Geometry. Now in the mirror modifier, under Mirror Object, you can specify which object's origin the mirror should use. Simply click on the eyedropper tool here, and then select this object. Awesome. Alright, activate the Y-axis as well, and you'll see that all four caps are now in the correct position. Alright, if you like, you can fill these open caps as well. It's very simple. First, delete the subdivision surface modifier, then right-click, convert to mesh, and re-add the subdivision surface. Okay, let's hide this object. Select this edge loop, then press E and then S. Now add a supportive edge loop with Ctrl R, click and bring it close to this part. Adding one here would improve it even more. Okay, then select this edge loop again and press F. Okay, and now repeat the same process for the other side. And that's it. Alright, now let's move on to the next part, which is modeling this section. Before that, I'm going to select this part, and as you can see, this curve has become a bit deformed. If I go into Edit Mode, you're going to see it's because of these two edge loops. So I'm going to select them and press X, and be careful not to select edge because something scary like this will happen. So remember to choose Dissolve Edges to remove these edge loops. Okay, you can see that this part is now fixed. Now I'm going to switch to the back view, and to create this section, we can actually use the existing geometry. To do this, let me move this part up a bit, okay? To do this, I'm going to simply press Shift D to duplicate it, and then right-click to place it exactly in its original position. Now I'm going to temporarily hide the main object. I'm going to select these two edge loops, then press G and G again to slide them up a bit. Alright, here's a really cool trick. Press S to scale, and now I want to flatten this edge. To do that, it's very simple. Press Z to select the Z-axis, type 0, and press Enter. you can see that the edge loops are now flattened easily, okay? Now I'm gonna add an edge loop here. There is no need for the other side because we can use the mirror later. Okay, I'm gonna select this one, then press S, Z, 0, and enter. Now I'm gonna select these faces and press Ctrl I to invert the selection. Then press X and select faces to delete them. Now I'm gonna press the / on the numpad to go into local view and select these back faces. And finally, I'm gonna delete them as well. Okay, press / again to exit the local view. Next, I'm gonna add a mirror modifier. Okay, I'm gonna select this edge, press E to extrude it, and extrude it along the x-axis. As you can see, these edges are intersecting. So I right-click to cancel, and be very careful because the extrude wasn't cancelled. So I'm gonna have to undo it with Ctrl Z, okay? To be sure, I'm gonna move this edge to check if there is any extra face here. And it's okay, I'm relieved. And now to prevent the edges from intersecting, just enable the clipping option in the mirror modifier here. Okay, now I'm gonna extrude this edge, and you can see that no matter how hard I try, these edges won't intersect anymore. Okay, I'm gonna click here, and you're gonna see that these edges aren't connected. If I disable the subdivision surface, you're gonna see that's where the problem is. So I'm gonna turn it back on, and just swap the order of these two modifiers. So the mirror happens first, and then subdivision surface smoothes the geometry. Once again, we've realized the importance of modifier order. Now I'm gonna select this edge and extrude it, press S, and this time to flatten this edge, I'm gonna select the x-axis. Okay, type 0 and press enter. I'm gonna add a supportive edge here, again S, X, 0, and enter. I'm gonna add an edge loop in the middle here, then move these vertices a bit to this side. I'm gonna also move this edge a bit, and that's it. Alright. Now to give it some thickness, press A to select all the faces, then press E to extrude the meshes outward. Now just add 2 supportive edge loops to this part so that the edges become sharper and the thickness shows better. Okay, now I'm gonna unhide the object, and you're gonna see that this part needs some adjustments. Okay, I'm gonna press Alt Z so I can see the vertices better. I'm gonna select these vertices, press G twice to slide them to this side to fix the problem. Alright. If you like, you can also slide these vertices a bit to this side to make this curve a little smoother. Okay, there is not much left to do. I'm gonna create a UV sphere and reduce the segment count to 16. 32 is way too much. I'm gonna press R and rotate it 90 degrees along the x-axis. Right, enable shaded smooth. I'm gonna go back to the back view and scale it down. Press the period on the numpad to zoom in and scale it down a bit more. Okay. I'm gonna go to the right view and move it further back. I'm gonna also adjust its position. I go into local view, select these vertices, press X, and select vertices to delete them, since they won't be visible, okay? I'm gonna exit the local view and scale it down along the y-axis. Finally, I'm gonna add a subdivision surface modifier with a level of 1. Now I press Alt-D to create a linked duplicate, move it over here, and create another linked duplicate and move it to this side. This way, whenever we need to, we can modify one of them and all of them will be updated simultaneously. And there you have it, everyone. The modeling of Andy's chair is finally complete. I really hope you found this episode both informative and enjoyable. Your likes and comments truly motivate me, but as I mentioned in the first episode, nothing would make me happier than seeing you follow along and create the models yourself. Keep up the great work, stay inspired, and I'll see you in the next episode. Take care and goodbye for now.